semester, we were approached by a team of engineers in Uganda who created a belt to treat postpartum hemorrhage, or PPH, in low-cost rural settings. In order to bring their product to clinical trials, they needed to test the safety of their belt as well as collect specific data points to prove that their belt works. That's where we came in. This semester, our group created an accurate model of the female abdomen postpartum that mimics the elasticity of the human body, the pressures produced in the uterus, and the blood flow circulation. Our belly dummy integrated a latex tubing flow rate system, ballistic gels, pressure sensors, and mock silicone organs to create a functioning masterpiece.
The design criteria of our belly dummy included mimicking a uterus postpartum in an anatomically accurate way, as well as incorporating a circulatory system to stimulate blood flow. To mimic the uterus, we used a combination of gels. We casted and molded an ellipsoid-shaped uterus out of a combination of EcoFlex 300 gel, a gel that best models organs, and a slacker gel that softened the uterus to the accurate level of pressure reception needed. We then coated the uterus in a layer of dragon skin gel, which closely mimics the qualities of skin.
The success of our client's PPH belt was dependent on the belt's ability to lower the blood flow of the system. Therefore, in our model, we needed to create something that would simulate blood flow at the proper rate of 205 milliliters per minute. In order to do so, we used latex tubing to develop an artery system that, using Y connectors, water would be entered through the arteries and then water would come out at the end with the ability to measure the change in volume.
Since different parts of the body are made up of different materials and tissues, to most accurately represent the female postpartum torso, we had to prototype these different body parts separately. Some of these organs that we focused in on were the bladder, the colon, and the small intestines. We focused on these organs because these are the ones that directly surround the uterus, and they will be directly applying pressure to the uterus. So, we thought that it would be important for these organs to have the proper size, shape, textures, and elasticities to correctly distribute the pressure onto the uterus.
Our team designed and created an interface through which the signals from the pressure sensors were interpreted to be sent to a computer.
We used FlexiForce sensors along with Arduinos and Python to create this lovely graph that appears before you.
The exterior of our model was comprised of dragon skin, which is a silicone rubber mixture tinted with silicone dye. The interior filling was ballistics gel, which helped integrate each of the organs together. Ballistics gelatin creates the feel of real human flesh and was cost-efficient to create. However, it was only temporary because it breaks down when not refrigerated. In the future, we hope to use a more durable material to meet our design criteria of 300 uses and lasting 1 year. We created a 3D printed pelvis to provide a support for the system.
For our future plans. First, we want to expand the sensing and circulatory technology to other organs in order to test pressure and blood flow for the other affected body parts. Second, we want to increase the accessibility of belly dummy in Uganda by finding and utilizing materials that are suitable for low-resource environments. Finally, we want to increase the durability of the model by finding more durable solutions specifically for the ballistics gel.